Hello, let's look at another type of question from exponential equation. Here we have to show that this term on the left hand side of the equation should equal x divided by y to the whole power 2m. So let us at first take these four expression on the left hand side and try to solve it. Here I've copied the same right hand side of the equation. Now at first what I'll do is I'll check the LCM of this first term, x plus 1 divided by y. So for this first term I can take y as the LCM, and in place of x we can write xy plus 1. Becomes our xy plus 1 becomes our numerator, and y becomes denominator. There is no change with power right now. I'll do the similar calculation for these remaining three terms. I'll just take the LCM. So this is what I get on taking the LCM. Now one more thing we can see over here is all these four expressions, they've got the same exponent, or they've got the same power, which is m. So what we have to remember here is if we have two different bases, one on numerator which is x and another on denominator which is y, but they have the same power, which is a, sorry, here is a. So if we have different bases and they have same power, so we can combine these bases like x divided by y, and since they have same power we can represent it as the single power for both these terms x and y. So this expression, the first expression, can be represented in this form. It's our rule for indices. We can do the same for these two terms and these two terms, or also we can do it at the same time, but it will be easier if we take two terms at a time. So for these two terms, what I'm gonna do is I'll write the numerator of the upper part, which is xy plus 1 divided by y, and this is for the denominator part, which is x plus y divided by x. So I can represent it as the same power m. Similarly we can do it for the remaining two terms right here. So this is our numerator, or this is our first term of numerator, this guy right over here, and for this denominator I'm gonna write it just below it and give it a single power, which is m. I hope you got the concept for what I did right now. Now once again, for this first expression, what I'm gonna write is take the reciprocal numerator. This becomes the numerator and y is its denominator, but this x becomes the numerator and this numerator becomes the denominator. It's just a simple reciprocal. For example, if we have a fraction in this form, a divided by b divided by c divided by d, we have to first write this numerator part, which is a divided by b, and this d comes upward over here and becomes the numerator, and the c becomes the denominator. So for a divided by b divided by c divided by d, we can write a divided by b times d divided by c, which is the concept for reciprocal. I've done the same for this first expression, and I'll do the same for this second expression as well. On doing so, I got this term multiplied by this term, the product of these two terms. For further simplification, I can just cancel out xy plus 1 on numerator and xy plus 1 on denominator. Similarly, xy minus 1 on numerator and xy minus 1 on denominator. So the remaining portion here for this first expression is xy divided by m, and for this second expression is xy to the power m. So it's this is what remains after simplification. So further, what we can do here is the bases, which is x divided by y, are same in both. Here we've got two similar bases. So we know the rule of indices. If we have got say x to the power a times x to the power b, two bases having different power or same power, we can simply represent these two bases as single base and add their power. So we can do same for this two term. For this, first of all, let us write our base, which is x divided by y, and simply add their power. So this gives x divided by y to the power 2m, which we have to show according to our question. So we've simply shown it right here. So we've done what the question wants us to do, so it's proved. I hope you got the concept here, and yes, thanks for watching.